Right now, on the floor of a dead river delta on Mars, there is a sealed titanium tube about the size of a cigar. Inside it is a few grams of rock, and inside that rock may be the answer to the oldest question our species has ever asked. In September 2025, NASA stood up in front of the world and said something no space agency has ever said with this much confidence. We may have found a signature of ancient life on Mars, not a hint, not a maybe from a blurry photo, a peer-reviewed, Nature-published, potential biosignature. It came from a rock with leopard spots. This is the story of how we got here, a century of dashed hopes, dead robots, and false alarms, and why this time really might be different. Start with a fact that still feels illegal to say out loud. Mars was once a water world. 4 billion years ago, while Earth was still sorting itself out, Mars had rivers, lakes, river deltas, possibly an ocean wrapping its entire northern hemisphere under a thicker, warmer sky. We know because the evidence is carved everywhere. Dry riverbeds you could hike, lake beds with shorelines, pebbles rounded by flowing current, chemistry that only forms in standing water. On the one world next door, it rained. Then Mars died. It's a smaller planet, so its molten heart cooled and its magnetic field, the invisible shield every living world needs, flickered out. Without that shield, the solar wind went to work, stripping the atmosphere into space, atom by atom, for a billion years. The rain stopped, the rivers sank into the ground or froze, the planet rusted. The water never actually left, though. Orbiters have mapped vast reserves of ice sleeping just beneath the surface across half the planet. The water that carved those rivers went to ground and froze and waited. But here's the question that has haunted science ever since. Mars had water, warmth, and chemistry for hundreds of millions of years. On Earth, that was enough time for life to start. So, did it? We've been burned before. Around 1900, the astronomer Percival Lowell peered through his telescope in Arizona and saw canals on Mars, a dying civilization's irrigation network, he said. He wrote best-selling books. The public was electrified. The canals turned out to be an optical illusion. Lesson 1 on Mars: wanting to believe is dangerous. The canals died hard. When the first flyby probe reached Mars in 1965, its handful of grainy photos showed craters, a dead, moon-like world. The public deflation was so complete that one newspaper editorial pronounced Mars the disappointment of the century. From irrigation empires to craters in 22 pictures. In 1976, the Viking landers touched down and ran the first life detection experiments on another world. One test came back positive. Nutrients added to Martian soil released a puff of gas, exactly as living microbes would. The champagne stayed corked, other instruments found no organic matter at all, and most scientists blamed weird soil chemistry. The debate over that puff of gas has never fully ended. Then in 1996, Mars fever returned, carried by a rock that fell to Earth. Inside a Martian meteorite recovered in Antarctica, NASA scientists reported structures that looked like fossilized nanobacteria. The President of the United States announced it from the White House lawn. Within a few years, nearly every line of evidence had crumbled. Chemistry could explain it all without life, burned again. But that false alarm did something lasting. It created the entire modern field of astrobiology, the programs, the instruments, and the hard-won rules of evidence that everything since has been built on, including the rules that would one day be applied mercilessly to a spotted rock in a Martian riverbed. So NASA got disciplined: follow the water first, then look for the ingredients. Rovers found ancient habitable lakebeds. They found organic molecules preserved in mudstone. They caught methane whispering in and out of the atmosphere. Every box ticked except the one that matters. Which brings us to Jezero Crater. 3.5 billion years ago, it was a lake fed by a river that built a textbook delta, the exact kind of quiet, muddy environment where on Earth life gets fossilized. In 2021, the rover Perseverance landed on it. Getting there required the most terrifying 7 minutes in spaceflight, a plunge through the atmosphere behind a glowing heat shield, a parachute opening at supersonic speed, and finally a rocket-powered crane hovering over the delta, lowering the 1-ton rover to the ground on nylon cords before flying off to crash deliberately in the distance. It worked. It has now worked twice. Perseverance is a robotic field geologist the size of a car, and it carries something no Mars rover ever has: a drill that packs samples into sealed titanium tubes, built to survive a trip back to Earth. It even brought a passenger, a 2-kilogram helicopter named Ingenuity, designed to fly 5 times as a technology stunt. It flew 72 times over 3 years, the first aircraft ever to fly on another world, scouting the rover's path like a hunting dog in an atmosphere 1% as thick as Earth's. In July 2024, in a dried river channel called Cheyava Valleys, it rolled up to an arrowhead-shaped rock the team named Cheyava Falls. And that rock was covered in something extraordinary, pale spots each ringed with a dark halo, leopard spots. On Earth, patterns like that form when microbes eat organic matter in mud, driving chemical reactions that leave mineral rings behind. The rover's instruments found the full package in that rock: organic carbon, ancient mud, and two minerals, vivianite and greigite, that on Earth are routinely produced by microbial metabolism. In other words, the chemical leftovers of what could have been a meal. Something 3.5 billion years ago may have been eating in that mud. And crucially, the rock never got cooked. The minerals show no sign of the heat or acid that can forge these same patterns without biology. Whatever wrote those leopard spots wrote them cold, in quiet mud, which is exactly how life writes them here. Now this is the part where every honest science channel has to pump the brakes. A potential biosignature is not proof of life. Chemistry can fake it. Heat and pressure can produce those same minerals without biology. The team spent a full year trying to kill their own result, and non-biological explanations became harder to sustain, but not impossible. That's why the sample matters. The rover drilled Cheyava Falls and sealed the core in a tube named Sapphire Canyon. To settle this, really settle it, that tube needs to come home, to labs the size of buildings that can interrogate every atom. And here's the cliffhanger nobody wanted. The mission to retrieve it is over budget, redesigned, and not yet scheduled to fly. The plan, when it finally flies, is audacious. A lander touches down beside the cache, loads the tubes into a small rocket, and that rocket becomes the first machine ever launched off the surface of another planet, handing the samples to an orbiter for the long ride home. Every piece of it has been designed. None of it is fully funded. On Earth, the receiving labs are already being planned, sealed facilities where the tubes would be opened behind layer after layer of containment, partly to protect the samples from Earth, and partly, just in case, to protect Earth from the samples. So the strongest hint of alien life ever found is sitting on a dead riverbed, sealed and labeled, waiting for species 40 million kilometers away to decide it's worth the postage. Maybe it was nothing, maybe strange chemistry, one more time. Mars has taught us humility for over a century, from Lowell's canals to Viking's puff of gas. But maybe in a quiet lake under a kinder sky, while our own planet was still finding its way, something lived next door. If that's true, then life isn't a miracle that happened once. It's what the universe does whenever it gets the chance. Two worlds, side by side, both alive. That changes the odds everywhere, for every star you can see. And there's a real chance the answer doesn't come home in a robot's cargo hold at all. It comes home in a geologist's. Every serious spacefaring nation now has human boots on Mars somewhere in its plans for the coming decades. The first person to hold Cheyava Falls in a gloved hand may already be alive. They may be watching videos like this one. The answer is in the tube is waiting, and one day, maybe sooner than you think, somebody is going to go get it. Next time we go all the way back, before Mars, before Earth, before the first star ever burned, to the first second of the universe. What actually happened at the beginning of everything? The honest answer is stranger than any myth, and it's written in light that is still falling on you right now from every direction in the sky. The first second, the oldest light, and the moment the universe almost didn't happen at all, that's next.